Hello everybody, today we're going to be doing 4.07 and 4.08 energy sources. Alright, let's go. Okay, energy resources. Energy sources can be renewable or non-renewable. Wood can be grown back, but oil takes millions of years to form. Renewable energy sources can be renewed, while non-renewable will eventually deplete and run out. So wood, for example, is renewable. Coal and oil, that is non-renewable because it will eventually deplete. Non-renewable energy resources. Fossil fuels discovers a wide range of energy sources including coal, oil, and gas. They're called fossil fuels because they are formed from fossils. Animals and plants millions of years ago decompose and form oil today. Most fossil fuels release greenhouse gases, and this will cause the greenhouse effect. The greenhouse effect. So, you've always heard greenhouse effect. You don't know what is greenhouse effect. So, greenhouse effect is I don't know if you could see that, but it basically says that CO2 and other greenhouse gases, it traps heat from the inside the atmosphere. So the sun shoots out light and then it comes back down, so it just keeps on bouncing up and down, and it will always stay in the Earth's atmosphere, making the Earth hotter. So that's what the greenhouse effect is. Natural gas. It is the cleanest of the fossil fuels, but its method of obtaining it is quite destructive. To obtain it, you need to pump high pressure water into the ground, opening up the cracks and releasing trapped gas. Obviously, cracking open the earth doesn't sound like such a good idea. It's called fracking, and you just pump water with fracking chemicals, and then the gas is called shale, by the way, and we break open it, and then after that you get pumped back up. But sometimes the fracking chemicals goes into the water, the drinking water supply, so that's why it's kind of dangerous. So all the people who are doing this, maybe they should frack off. Nuclear fuels. Nuclear fuels are incredibly efficient, storing up to 55 tons of energy in just 1 kg of uranium. The problem is that it is expensive and dangerous. Uranium could also be used as nuclear weapons. So yeah, it's pretty clean. This is nuclear fusion. So you fire a neutron into an atom and it'll become unstable. It'll break off and then energy will be released. And then it'll release 3 neutrons, and the neutrons will bump into more atoms, and they'll cause more and more and more reactions. So it's like a domino effect, That's why it's kind of dangerous. Yeah, it's dangerous because here's an example of what happened in Chernobyl. Yeah, that's Chernobyl. It exploded in April 26, 1986. The nuclear core overheated and it melted through the casing, making the power plant unstable, and soon it exploded. 31 people died, 15 more from radiation. Yeah. However, this was a long time ago when safety was quite loose. Nowadays, they are researching new ways to safely undergo fission without a chance of overheating. For those who are interested, they are using thorium nowadays and plutonium. So plutonium needs to be activated with thorium, and without thorium, cannot undergo fusion. So therefore, if you remove thorium from the equation, it will not overheat. So that's why it's so safe. Next, renewable energy sources. Hydroelectric energy. You build a dam and you poke a few holes in it. You put a fan in the holes and you have energy. As you can see, water flows down through there and then goes into the fan and then it goes back out. This is not a new method of obtaining energy. One of its old uses is to grind corn using a water mill. That's a water mill, by the way. This method uses gravity and the sun's energy. This method uses the water cycle. So water that comes out of the dam, it gets evaporated, it goes up, and then it rains back down into the dam. and it's just an endless cycle of energy. Tidal energy. Water comes in and out. It rotates and defines, creating energy. So yeah, that's what tidal energy generators look like. The waves come in and out and rotate the fan. It's quite expensive to build and not as efficient as hydroelectric energy. And also, it's kind of more like a concept right now. It's not really used. Wind energy. This is pretty self-explanatory. The downside is that it's big and loud, and some places don't have very much wind. Yeah, people also use it to grind corn back then, using windmills. And yeah, the wind rotates the blades, and inside the middle of the blades there is a gearbox, and the gearbox rotates. It rotates a generator, making energy, making electricity. So wave energy, almost the same as tidal energy, but uses the up and down motion of the waves instead. It is difficult and expensive to build. So as you can see, it's like there's a few floaties in the middle of the ocean. It goes up and it goes down, and then it creates energy. Quite expensive, as they said. Alright. Geothermal energy. It's pretty hot. Geothermal energy is using the Earth's core to heat water into steam and run it through a generator, making power. So as you can see, step 1, hot water comes up, and 2, it goes into steam, and 3, it goes into the turbine and powering the generator, and then 4, it goes into a cooling tower where it goes back down into the injection well and gets heated back up, and the cycle repeats. Geothermal energy is heat produced by the Earth's core. The Earth's core is really hot, and it's made like solid steel, molten steel thing? Not steel, I mean iron and nickel. Solar energy. Solar energy uses the energy radiated from the sun. Solar panels absorb this energy and make electrical energy. Yeah, it's pretty simple. Most people use this in their house these days. This is one of the most common renewable energy resources. Biofuels, made from plants or animal matter. Wood, methane gas, alcohol, etc. Biofuels also include food, which we use for fuel, and animals use for fuel. Alright, 4.08. How we get energy. Energy from the sun. Solar panels. Again, this is from last chapter. Energy from the sun radiates down into Earth, and solar panels absorb it, turning it into electricity. Energy, food. Alright, there's energy from the sun radiated into Earth, and then the plants, they absorb it, and then we eat plants. But animals also eat plants, and the animals eat the plants, and then we eat the animals. So therefore anything that is alive gets its energy from the sun. And so yeah, energy is food. Biofuels. This is included as food as well as wood and alcohol, as said before. Plants, this is, as said before, you energy radiated from the sun, absorbed by plants, and then we eat plants, and animals eat plants, and we eat the animals. So there you go. Fossil fuels. Again, the plants and the animals, they eat they get energy from the sun, and then after that, the the animals, they die and decompose and become fossil fuels. Yeah. The weather. Now, the energy radiated from the sun, it heats up some parts of the earth, but not evenly. It heats up some parts of it, and due to expansion of the gases, it creates winds, and these winds are what causes our weather. And we take advantage of the weather using wave energy, because the waves get pushed, and then we use the wave energy. And hydroelectric energy, it heats up the water, and the water system, it gets evaporated and then goes back into the dam and goes back down. Wind energy is from the weather, And here's a new one: nucleus of the atom. So the geothermal energy, what you might not know, is actually from the rocks. It's heated from the rocks. It comes from the naturally radioactive material occurring in the rocks. And nuclear energy. Nuclear energy is the power of the nucleus of the atom. And next is tidal waves. In fact, this is the last one. Tidal energy is the power from the moon, the attraction from the moon. We take advantage of that and we get tidal energy. Alright, that's all. I'm gonna end it now. Goodbye.